Then you have V3 is equal to 3 already. Okay, that is known. So you have two unknowns, V1 and V2. So you have two equations, two unknowns, you solve for them. Okay, I won't go to the algebra. Two equations, two unknowns. Equation 1, equation 2. Okay, you can go to the algebra and solve for them. I won't go through that because I don't have time. Okay, we can go through another example. Unless you want me to go through them. I will go through them, right? You want me to go through solving those two equations for the two unknowns? Not necessary, right? It's pretty systematic. You just crank and crank and crank. And then you get those two unknowns coming up. Let's do another example. This one is also from the textbook. This is the voltage control current source. And then I have a branch that looks like that. And then I have Vx equal to V2 over 2, okay, for this reason, if this is Vx, and this is given to be 3 ohms, and this is given to be 3 ohms, okay, and this is V2, and this is V1, it's known. Okay, how do I solve this problem? Let me get the other numbers from the textbook. Okay, the other numbers are 2 ohms. And this is 1 amp. And this is grounded. Okay, so what do we do? We first apply, say, KCL at this node. We assign voltages and apply KCL at that node. Okay, so the current V1 minus V2 over 2 is equal to V1. There's a current flowing here. Okay, and then there's a current over here. And then these two currents should add up to 0. So let's apply KCL at node 1. At node 1, we would have V1 minus V2 over 2, which is the current flowing that branch, should be equal to minus or plus 2Vx is equal to 0. The total current leaving that node must be equal to 0. So if I write this again, then 2Vx is equal to V2. Must be equal to 0. So this is KCL at node 1. And then at node 2, this node over here, okay, this is node 1. At node 2, okay, at node 2, which is this node over here, then I should have V1 minus V2 over 2. V1 minus V2 divided by 2 is the current flowing in this direction. Okay, that current coming here. And together with this current, and together with this 3 current, they should add up to 0. Okay, so plus 1 amp, which is the current coming out here, and then plus this other one. Okay, plus this other current should be V2 plus, let's call this 0 volt. Okay, this current flowing there, okay, this current flowing in that direction is just equal to 0 minus V2 over the total resistance, which is 6. And this must be equal to 0. Okay, so you have equation 1, and you have equation 2, and then you can solve for the two unknowns, V1, V2, solve. Okay, solve these two equations, and then you have this problem solved. Okay, are there any questions regarding this method? First, step 1, assign voltages to every node. Step 2, write KCL for every node. Step 3, solve the equations in law. And make sure that the number of equations you have is equal to the number of unknowns you have. If they're not equal, then you're in trouble. You cannot solve them. You have to keep looking, okay, for more equations. Okay, very, very simple procedure. And let's go to a, yes?
A node 1 is V1 minus V2 over 2, a current.
V1 over V2 is a voltage drop across this resistor. Okay. Then this voltage drop divided by 2 is the current flowing here. Okay, let's call this IA. This part is IA, right?
Yeah, and then is that 2Vx? Is that?
Yeah, this current, this is a voltage control current source. Okay, let's call this IB. Okay, IA is this branch of the current, IB is that branch of the current. The current that's flowing downward is given by this. Okay. These two currents must add up to 0 by KCL.
Is Vx a voltage?
No, Vx, this is called the voltage control current source. This is a current source. The current that flows in this branch is controlled by this voltage drop over here. Okay, so it's not an independent current source. So that's why it's a current source that depends on Vx. And this two should add up to 0. But Vx, as you can see from this branch, by the Kirchhoff voltage law and the law of a voltage divider, this is just a voltage divider. So Vx must be V2 over 2. Because these two just divide the voltage into half. Okay, so Vx becomes V2 over 2, and when you multiply, let me write down Vx. Is V2 over 2. Right? You plug that in, you get the other equation.
Yeah, I get it.
Okay? Any other questions? Don't feel shy, yes?
So the unit of Vx is amperes or voltage?
Vx would be in terms of voltages, but this is a current. So this should be something in terms of amperes. But this 2 should be given a dimension. Okay, 2 should be 1 over ohms. Okay, 1 over is Vx divided by R that gives you current, right? So this 2 shouldn't be called a pure number. It's a number that has dimension of 1 over resistance. Then everything will come out to be dimensionally correct. So sometimes there's a danger of working with just pure numbers. Then you cannot express the dimension of that. Okay, so this should be 1 over resistance if it's going to be a number. Okay, are there any other questions? Yes?
Can we first use the series equivalent to get 6 ohms?
Well, you could, but then this problem stipulates that this current only depends on this voltage. Of course, you can add these two together and get 6 ohms, right? But then the voltage over the second resistor, you might not know if you have consolidated it. This problem specifically say that that current source is dependent on this voltage. Okay, if you consolidated it, then you don't have that voltage. You can do that, but then you have to be mindful that you have this problem. Okay? Let's look at the, yeah, you can ask more questions because I have only about 3 minutes left. If I start something new, then I probably cannot finish. So you might as well ask as many questions as you can on this, yes?
So why do you use a 0 subtract V2, not V2 subtract 0?
Oh, it's the same. If I want the current flowing in this direction, it's this voltage minus that voltage divided by the resistance. If I want the current flowing in that direction, I want V2 minus this voltage divided by the resistance, right? If this is R, this is V1, this is V2. If I want the current flowing in this direction, is I is V1 minus V2 over R. Not necessary. You have to see the direction of the current. This direction of the current is this voltage minus this voltage divided by R. This is Ohm's law. Okay? And you have to get this straightened out. It's always this voltage minus this voltage. You can also think that this is higher than that, but that's not necessarily so. Sometimes this can offer you a negative sign. Then the current will go in the opposite direction. So I can think of this as being higher, this has been lower. But be mindful that that could be a wrong thing. Okay. Because sometimes V1 minus V2 give you a negative number. Okay, I guess you can go. I have only 1 minute left. So you can ask whatever questions that you like.